Alright, I just completed the video of this analysis of this constant current source with two transistors, and here it is still on a breadboard. Just disconnected it, but I wanted to go ahead and make this into a circuit board so I can keep it, as a test sample of known, since I analyzed the shit out of it on a spreadsheet and everything. It'd be nice to have a known standard, okay, to compare it against if I want to come back and do experiments with that later. At least I know some of its properties already. So what I did was, I went in and took it's just a piece of copper clad, single-sided board, but you can use double-sided for this technique too. I took a pencil, basically, not this pen, but I took a pencil and I drew the pattern of what I want to cut, so you can see, here where I'm going to make my cuts in it. Right here, that's the emitter of the transistor you see on the left. That's the collector of the transistor you see on the left. That's its base. Here's our 330 ohm reference resistor, where it's going to go. And this down here is the base, emitter, and collector of the second lower right transistor. And here's our 10K reference resistor, and here's our ground connection, and our two outputs here to our load, will be there. And what's nice is too on this is you can like draw on the back, right on the back, and so 30 volts input, ground, two output connections. So, and what's great about what I'm going to do is I'm going to carve these, out with a Dremel tool, basically. And usually you can use a grinding wheel or something. I'm going to use a disc this time, and hopefully it won't explode on me, shatter. But sometimes I'll use a broken router bit, too. I have never tried it with a V-score router, but those little actual router bits you get that are vertical, almost like little end mills when they break off. Well, they're still usable, for things like this with a Dremel tool. You can really carve through circuit boards with a broken router bit quite easily. You don't have to worry about it breaking again. It's usually really short. But at any rate, I've got a wheel already loaded to my Dremel tool, so I figured I'd just use that. Here's where a positive supply, will connect to. But the great thing about this is you don't need to drill any holes. And it's basically a surface mount technique, and so it makes it real easy to change out components if they break on you or something like that, because they're all just really surface mounted on this thing. I mean, in fact, I use this as a poor man's connector strip too. I'll for like wiring, I'll take lengths of circuit board like this and I'll carve just routes in it so I can make it as a wire terminal block, and you mount that. Oh man, that makes it so easy to connect up shitloads of wires, inside some project or housing. I've used that technique many times, and it's real simple to make, and they're real good connections as opposed to using some kind of more expensive than this terminal block or something. So if you got a lot of copper clad lying around, it's great. And the other nice thing too is if you got double-sided, you can use it exactly the same way, or you could extend the circuit that you're building onto the back, or put a totally different circuit on the back. So, so it's a really versatile little technique. It's only good for really rather simple circuits for obvious reasons, but, it's come in handy a number of times, and I'm going to demonstrate. And this is actually easier to make and assemble, I think, than a perf board is, quite a bit. But at any rate, it's real easy to determine the diagram just based on, my schematic over there on the, on Fallstat. But let's, that Dremel tool here, and I'll see if I can get maybe a broader view here. So I got it set, kind of on low. Try not to point the disc at me. Normally I do this under a magnifying lamp. I think I'm going to have to do it under a magnifying lamp just so I can make sure I'm getting good cuts through it. So, probably turn it up just a little. Let me turn my iron on. You can do this in a vise if you want, but it's easier for me to hold it because then I can change the orientation dynamically. So it's got our first route done. I'm going to do this bottom one. Because if this thing shatters, it'll probably stick little pieces of fucking cutoff disc in my hand. That's why I don't like using these cutoff discs very often. But they are fast. Yeah, see, it does shit like that. Little fucker. Little fucker ain't gonna get me. It's kind of dusty with these discs. See, I think there's a little... You know, you don't have to worry about burrs too much with this method either. And it's sure a hell lot better than dealing with chemicals like ferric chloride or whatever, that's for damn sure, and all the time that takes. So this is, you know, good for quick and dirty little circuits. It's just a real handy technique to use, so, you know, you can see what the good to the back of it. But that's pretty much it for the circuit board. So, put the Dremel tool away. You know, wipe the dust off here. Okay, so now I will pick the components off of my circuit board. I'll start with a 330 ohm resistor, which I kind of scorched because I accidentally shorted it out with while I was trying to connect probe leads or oscilloscope leads to that stupid circuit, and I didn't notice that I short-circuited something, and that's why having a constant current source on a power supply is a good idea when you use it properly. Unfortunately, I left it set at 67 milliamps, you know, but you should always adjust that CCS down to your circuit just in case something like that happens. Then it won't likely damage the circuit, but I didn't do that. It's like right now I got it set at 8 milliamps, and that's what I should have had it at because this is like a 3 to 5 milliamp circuit, but you know, I neglected to do that, so I had to throw the damn transistors away and replace them because it damaged it. Okay, so here's my soldering iron. Now the great thing about this too is you don't even have to clip the leads. But at any rate, the next step you do is you go in here and you put solder, you know, a solder pillow where every connection is going to be ahead of time. So that, okay, here's for the voltage wire, here's for this resistor here, let's see, here's for the base of that transistor, here's for its collector, put a little more there, and here's for the base of this other transistor. Here's for the emitter. Here's for the other 330 ohm resistor lead. Here's for the collector of that second transistor. Here's for a 10K resistor. One lead, 10K resistor, second lead. Stupid. Here's our ground wire, which I will cut this board off when I'm done soldering it. It's easier cutting it off after the fact, you know, because it kind of helps you maintain control of it. So I usually, you know, I'll go Dremel the bottom of this off when I'm done. But anyway, that's all of our solder pillows. Okay, I'll try to need to get me a separate soldering iron holder down here. Let's see, what did I do with the damn resistor? Shit. Oh, nope, that's not it. What did I do with it? Hold on a sec. Okay, I found the goddamn thing. Now what I'll do, you know, like I said, on something like this is, you know, if I can get this stupid cord out of the way here, probably gonna hit the camera. Okay, yeah, but what I'll do is often, like, okay, this component's still got its leads on it, right? You just kind of bend them up to the length you want, and you can trim them later instead of trying to cut them ahead. So, make it kind of like a Waterburger symbol. So, you know, so you got knees to solder to, and again, you just come back afterwards. Like I said, this is a 330 ohm resistor, so let me adjust the leads appropriately. And I'll just try to hold it with my fingers here. If you get the solder molten first, then you dip the lead in it and let it off before it burns your fingers. Voila. Okay. And the lighting in here is just dodgy as shit. What the fuck is going on? See if that helps. Okay, see, now I can't see it. Gotta use the stupid mag lamp, so you'll have to put up with the shadows. I don't know what to tell you. Okay, so let me get this next pillow flowing. I'll put it in it. It's a nice benefit of having long fingernails. You can kind of use those to sort of hold the components like this without getting too heavily burned. Okay, so it's got my resistor soldered in there. Now the next thing to do is our first transistor. Now let me make sure. Okay, make sure I know which is the base. Let's see, that's the emitter, the base is in the center. So yeah, now that's the emitter. Okay, so this bar pin here is the emitter. I'll solder that in first. It does help to, take and bend these, in a dog leg kind of fashion, a little bit. So I'll do that with all three of them. Okay, emitter, collector, and base is actually in the center on these. Really, I should verify that for sure, and I probably will. Just okay, so emitter, collector, and base. Oh, got the emitter. Man, this is bullshit. Okay. Do the collector. Okay. I'll get the base. That. Okay. First transistor mounted. Make sure there's no short circuits. That one is kind of close, but no, it's fine. Okay, now before I move any further, let me make sure. God damn it. Make sure I am doing this right. Well, let me turn that way to make sure to check the pin outs. That's why this damn thing is really handy for that. So I don't have to go to data books or anything. You know, usually it gives good results. So yeah, base is pin 2. You know, the collector is pin 1. So, you know, which is correct. And then pin 3 is the emitter, which is what I got connected to its right place. So yeah, that's correct arrangement. You know, check. You know, cut once, measure twice, as they say. Okay. Dog leg these. Alright, so here, you know, like I said, the emitter goes there, the base goes over there. I really should have bent some of those backwards, but yeah, my soldering iron cord's coming loose. Okay, so emitter. Probably ought to go ahead and clip that damn thing out of my way, but well, I'll do the base first. Okay. There's emitter, and then collector. Let's clear over here. Alright, so it's got that done, and now finally our 10K resistor. So let me W that up. Okay. That done there. I guess I could, you know, leave that available as a ground lead or a test lead if I wanted to, and I could leave that available as a power lead, you know, instead of clipping it off. But basically that's the complete circuit, but I'm going to go ahead and add some wires anyway, just for illustration purposes, if nothing else. Okay, so let me find, let's see, I guess I'll use a couple of orange wires, and green and a red. Now I got this, you know, old kit of old-fashioned jumpers they used to use on solderless breadboards. I got like thousands of these things. And they make good little wires, you know, you don't have to strip, so you can solder them to, you know, anything you want. So I mean, they're really quite handy. I imagine you can still buy those off Amazon. But yeah, they used to be real popular before those Arduino style jumpers became the norm. But anyway, I'll go ahead and straighten some of these out. I probably, before I solder, it depends on which direction I'm taking it off of. Yeah, I might just go ahead and solder to the ground of that lead. I'll probably go ahead and leave that resistor ground and power, because you know, it comes in handy to hook test equipment up to sometimes, having those extra leads. And see, these are already pre-tinned too, so they solder quite nicely. That froze. I'll probably put more solder on this. That's not bad though. So solder joints are real easy to inspect on these too. So okay, so where's the red wire? No. This is about the only kind of circuit board assembly, I mean, outside of assembling actual manufactured circuit boards, that, I actually don't half dislike. Otherwise, like I said, I hate perf boarding and I hate breadboarding quite a bit. So, at any rate, okay, so that's pretty much it for the soldered connections. Let me go ahead and clip some of the leads off that I don't need. So it's got that one. Again, I might leave that one here as a test point, if anything needs to attach to its supply. Again, I'll probably leave this one here just in case. Again, you want to hook test equipment and stuff to it, but beyond that, that's all the clipping there is to do. So let me get the Dremel tool back and go ahead and snip off the board here. Let me get this out of the way. See, that's why I don't like these things make me nervous as shit. How they jerk on you like that. They're just a bunch of jerks. Ah, shit, I just cut my... that's why it's probably better to do this. I'm going to have to solder that back on. No, I don't. I just almost cut this lead off. I pretty much did. That's no big deal, though. It's not necessary. Again, since you can see it on the other side, you can turn it over and do it from the back, and Bob's your uncle. So that's basically our little board there. So I did kind of fuck up the wire there a little bit with that, hitting it with that wheel, but okay, but I'll go ahead and just cut this thing off since I practically cut it off anyway. Alright, that looks fine. So, again, I could have maybe made the resistors a little shorter. I'd just like to leave them kind of long so you can hold them while you solder them with your fingers. Instead of having to use pliers, because then it becomes more cumbersome, of course. Okay, so I guess the real test is to hook it up and see if it works. So hold on a second. Okay, but yeah, it took me several minutes. I'm glad I spared you that to get it hooked back up. But yeah, so I mean, it's working, pretty much like it was working before. It's down to a lower current before, but it's cooled off since I hooked it up, and it is a different connected environment. But let's see if it still works as a CCS. Let me okay, so the voltage went from 15, 19 to 15. It's not working very well anymore. But it may just not be warmed up yet. Apparently, yeah, it's basically working. It just had to kind of warm up, I guess. Because I can go from 1.8 volts to 9.6 volts, and have it change. I mean, certainly acting like a constant current source. That's a lot more variation than I think I was seeing. But again, it's still not fully warmed up. Again, I did just hit it with soldering irons and everything, so that probably has something to do with it. But, that's one of the nice things about this technique, is that it doesn't really thermally stress components very bad, because you saw how quick I was able to make solder joints with it. I just heated the solder first and then dipped the lead into it and then removed the iron, and then, the solder freezes around it almost instantly. Use eutectic solder too if you can, 6337. But but yeah, I mean, it's basically working. And so, but again, it's a quick and dirty technique. It's not the prettiest thing, but I think it's a hell of a lot more serviceable. Can you imagine if you went and stuck this through a perf board, and had all these components going through holes and then solder joints, and then you blew a transistor? Well, if I blew a transistor here, I just have to reflow all these solders one at a time, and you know, prick the LEDs out of it, tip the LEDs out of the solder as I do it until I remove it, and then plop another one right in its place. There's no holes to mess with, no nothing, and these are pretty solidly mounted. They're pretty decent little joints. It's pretty hardy. So, as an assembly method, it's a pretty hardy way of doing things. And again, you can write on the back of it, and and even again, if you used a double-sided board, you could put a totally different circuit on the back or a continuation of the circuit that's on the top. So it allows you to kind of do things like that, but it's intrinsically a surface mount technique, which is also the technique I almost always used with wiring too on circuit boards. I almost always surface mount them like this. I mean, I've done that ever since I was in production on circuit boards. So, back 20 something years ago. So, anyway, just wanted to share that little technique because it's actually quick and dirty, but boy, it's just the best little assembly method, especially for simple circuits, that you can do. Obviously, if your circuit gets too complex, you should just break down and buy a JL PCB or whatever. I still haven't tried those guys out yet, but I'm anxious to. I'm really curious to see if they're full of shit or not. In the old days, people would bait you in with really low prices like that. Then you go try to order a circuit board from them again. They're like 10 times more expensive for basically the same thing. So, but from what I read out there, they don't, most of these newer companies don't do that. So, be it PCB Way or whoever the hell. But I've still never tried any of them out, but I'm looking forward to here pretty soon. I do want to try some of those guys out. I'm really curious because, like I said, that's the only thing I really like. Don't half mind doing assembly on is an actual circuit board, but breadboard bullshit, and definitely perf boards and stuff like that. I just really never ever cared for. That's why I've done very little of that in my time. So, because even as a kid, I hated it. Even as a kid, I tried making my own circuit boards. So, that was still preferable, even though more time consuming than. But that just turns into such an unserviceable mess when you use most of those techniques. I never liked it. They really fuck with my ADD because I get, confused by things like that. So, anyway, that pretty much wraps it up for this video. So, cheers. Oh.